Hello everyone, my name is Praveen Barode, branch CSE AIML, subject is Artificial Intelligence and Unit 2, topic is Knowledge Representation of Artificial Intelligence. Representation in artificial intelligence is a way to encoding information about the real world so that a computer system can reason, infer new facts and make decisions. The goals of knowledge representation are represent real-world knowledge accurately, enable reasoning and inference, be efficient and understandable, supports learning and updating knowledge. Problems in representing knowledge of artificial intelligence. Some major challenges are expressiveness, like representing complex and real-world situations, uncertainty, like handling incomplete and uncertain information, ambiguity, like same information may have multiple meanings, consistency, like avoiding contradiction in knowledge, scalability, like managing large amounts of knowledge, common sense reasoning, representing everyday human knowledge. Knowledge representation using propositional logic in artificial intelligence. Propositional logic represents knowledge using simple statement propositions that are either true or false. The components of logic representation, propositional variables like P, Q, R, logical connectives, AND gate, OR gate, NOT gate, implies gate, and if gate. The knowledge representation using predicate logic. Predicate logic, first order logic, is more powerful and expressive than propositional logic. The components of predicate logics are predicates, express properties or relations. Example, student X, variable X and Y, quantifiers, universal for all existential for their exist, function and constants. Resolution of artificial intelligence. Resolution is a rules of interface used in logic-based system to derive conclusions like words mainly with clauses in conjunctive normal form CNF used in automated theorem proving. Refutation. Refutation is a proof technique used to show that a statement is true by proving its negative is false. The steps of refutation is assume the negation of goals, add it to the knowledge base, use resolution to drive a contradiction. If contradiction occur, the original statement is true. The deduction of artificial intelligence in knowledge representations. The deduction is the process of deriving logically certain conclusions from given premises. For example, all humans are normal. Socrates is human. Therefore, Socrates is mortal. The deduction guarantees correct conclusion if premises are true. The theorem proving of artificial intelligence in knowledge representation. The theorem proving is a process of proving whether a statement or theorems logically follows from a knowledge base. The types of theorem proving is automated theorem proving and interactive theorem proving. The use of theorem proving is used extensively in artificial intelligence reasoning system, formal verification, and logic programming. Inferencing of artificial intelligence in knowledge representation. The inference is the process of deriving new knowledge from existing knowledge. The common inference methods are modus ponens, modus tollens, resolution, forward chaining, and backward chaining. Monotonic reasoning of artificial intelligence in knowledge representation. In monotonic reasoning, once a conclusion is derived, it cannot be withdrawn if new information is added. For example, birds can fly. Tweety is a bird that Tweety can fly. Even if later we learn Tweety is a penguin, conclusions remain. Non-monotonic reasoning of artificial intelligence in knowledge representation. In non-monotonic reasoning, conclusion can change when new information is introduced. For example, birds unusually fly. Tweety is a bird. Tweety can fly. New information arrived. Tweety is a penguin. Updated conclusion. Tweety cannot fly. Used in real world reasoning, expert systems, and common sense of artificial intelligence. There are the non-monolithic reasoning in artificial intelligence. Okay, thank you.